if a telescope is pointing at a star and both are stationary, then obviously the light comes straight into the telescope. In 1729, Bradley found that he had to tip his telescope forward very slightly to get a star in the centre of his telescope. It was assumed that this was due to the motion of the Earth around the Sun. Let us assume that the telescope was moving at 5 miles an hour and had to be tipped 5 degrees. This 5-degree tipping, however, could equally be caused by the ether moving at 5 miles an hour, carrying the stars around the Earth. As we see here, the light would be coming in at the same angle and the telescope would still have to be tipped 5 degrees. So tipping the telescope does not tell us whether it is the starlight moving or the telescope moving. However, there is a simple experiment that can determine whether it was the Earth that was moving or the ether and starlight. All that you had to do was record the tipping required for any particular star, then fill the telescope with water, which greatly slows down the speed of light in the telescope. So here is the moving telescope filled with water, tipped at 5 degrees, and you can see that the starlight does not now reach the eyepiece at the bottom. This is because the starlight moves much more slowly when passing through water. However, if the telescope is tipped further, say 10 degrees, then the starlight will then be visible again in the eyepiece. It has to be tipped further because the light is now slower when in the telescope. But if the starlight is going past the telescope at 5 miles an hour, then when it is filled with water, no further tipping is needed because the light is coming in at 5 degrees anyway. The starlight stays on the same path but is only travelling slower in the water. To recap, if it is the telescope that is moving, then when it is filled with water, it has to be tipped further to see the star. If the telescope is stationary and the starlight drifting past us, then it does not have to be tipped further. In 1871, George Biddle Airy, the Astronomer Royal, performed this experiment. This is a copy from his original report. You can see that the two readings are virtually identical. The result of Airy's experiment, known as Airy's failure, was that the telescope does not have to be tipped further. This proved that it was the incoming light that was moving past a stationary telescope fixed to the stationary Earth.
Only a handful of experiments in physics that completely transformed physics. At many people's top of the list would have to be the Michelson-Morley experiment.
In the 19th century, physicists thought that since sound waves travel through air, light waves must travel through some sort of medium as well. They called this theoretical medium ether.
The famous luminiferous ether. this magical medium that was hypothesized to be what light required to move through the vacuum of space, just the way sound requires air to move from one place to another. How else could waves of light move through the vacuum of space unless there was some medium there, some hypothetical medium? Let's call it the ether.
Ether, they theorized, is an invisible nothingness that permeates the universe. Its only physical property is that it allows light to propagate through it. But once precise measurements of the speed of light became possible, testing the predicted effects of ether on the speed of light became possible as well. The Earth orbits the Sun at about 66,500 miles per hour. If light travels through ether, they reason, then as the Earth moves through the ether, the speed of light should be different going with the ether than perpendicular to it. In an attempt to show the effects of ether on the speed of light, Albert Michelson and Edward Mورley conducted an experiment in 1887 at what is now Case Western Reserve University.
Michelson was an expert in optical experiments, and he thought that he could devise an experiment where one would be able to see the slight difference in the speed of light measured on the Earth if you measured it along the direction of the motion of the Earth and at right angles to it. There should be a slight difference.
Compared to the speed of light, Earth is not moving that fast. So if you're going to check the difference in the speed of light measured with the movement of the Earth compared with transverse to it, you need a level of precision that no one had before. The Michelson interferometer was just such an apparatus.
Michelson and Mورley devised an apparatus that would detect minute differences in speed between two beams of light. Light from one source is split into two directions through a half-silvered mirror. These beams are bounced between other mirrors and then recombined back into a single beam. When two light beams combine, if their waves are completely synchronized, the peaks combine to make an even more intense peak. If they are one half wavelength off, their peaks combine and cancel out the intensity. Slight differences in speed between two light waves will therefore produce a pattern based on the amount of interference between the two beams. This is known as an interference pattern. Examining the interference pattern from the two light beams sent out in different directions would clearly show if the speed of each light beam were different in different directions. But Michelson and Mورley never detected such a difference. Their results were inconsistent with the existence of ether.
The scientific world didn't know what to make of it. The famous scientists in Europe, Lord Rayleigh and Lord Kelvin and Lord Thomson, were saying, hey, come on, you must have done something wrong here. There has to be an ether. And the whole thing didn't get resolved until many, many years later when Einstein came along.
Einstein's theory of special relativity proposed that the speed of light is always the same, regardless of the speed of the light source. The results of the Michelson-Morley experiment were entirely consistent with Einstein's view of the universe, and this served as the turning point in modern physics.
The Michelson-Morley experiment was an experimental advance in technology that transformed science. Not only physics, but science.
The experiment sought to prove if ether actually existed, and this was attempted by using what is called an interferometer, which is an arrangement of mirrors designed so that a beam of light could be divided and sent in two directions at the same time. What they were looking for was a change in the velocity between the two light beams due to the interference of the ether stream. The result of their experiment was that the velocity remained unchanged regardless of the direction that the beams of light were sent. In other words, the result was negative. With this result, observing scientists told themselves that they had two choices: get rid of the ether entirely and all previous theories based upon it that dealt with electromagnetism, electricity, and light, or keep the ether and abandon the theory that the Earth is in motion. Essentially, if the ether existed to them, the experiment told them that the velocity of the Earth through the ether was exactly zero. Can one see the problem here? What would this do to public perception in regards to their home called Earth? If the Earth was moving exactly zero, meaning not at all, where exactly was it sitting? What exactly was our place in the universe? In 1905, at the age of 26, Albert Einstein published a paper that would in essence be the footprint for his special theory of relativity, which asserted that the laws of nature are the same for all uniformly moving systems. This again, for the scientific community, and thus the public, brought the Earth from its stationary position as related to the Sun, and without the use of ether, so to speak, set the world of physics on fire. What did this mean for all of us? A great deal if one is able to squelch through all of the tedious semantics and get to the true meaning of what this theory is actually stating. By accepting relativity as it stands, along with time dilation and all of its other relativistic properties, the world is accepting that there is no such thing as simultaneity, or what could be called the now. That's right, there is no such thing as now, which means that this science also gets rid of paradox and moves itself entirely into the realm of contradiction. To say that there is no now that is independent of a system of reference means that all conceptualization of a divine source goes straight into the trash bin.
To deny the ether is ultimately to assume that empty space has no physical qualities whatsoever. The fundamental facts of mechanics do not harmonize with this view. According to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there exists an ether. According to the general theory of relativity, space without ether is unthinkable.